welcome to Velocity. We're standing outside the offices of Velocity West, a branch office of Velocity Incorporated located in Sebastian, Florida. Today we're going to introduce you to the Velocity Group. We're going to talk a little bit about the kit you're about to receive and give you a preview of the materials you'll be working with to build your Velocity. So let's go inside and get started. The Velocity Group is currently made up of 3 geographical locations. The first is the home office and factory of Velocity in Sebastian, Florida. The second is this location, called Velocity West, located here at the Lincoln Regional Airport in California. And finally, our representative in Western Europe, a company called Future Aviation Europe, located in the Netherlands. All 3 of these locations comprise what we call the Velocity Group. Most of our kit components are manufactured at our home office and factory in Sebastian. The Lincoln office, again a branch of the home office, provides representation and builder support for those builders located in the Western United States. Our Netherlands office provides the same for Western Europe. All the locations offer kit sales of all additional Velocity products, information distribution, aircraft servicing, and most important to you, the builder support. Now that you hopefully know a little more about the organization you're involved with and where builder support is available, we're going to give you a quick overview of the materials you'll be working with and some basic recommendations on how we feel you can get your airplane flying quickly and safely. So let's head out into the hangar and get started. Hello again. As I mentioned inside, what we now want to do is try to get you a little more familiar with the materials you'll be using to construct your Velocity, at least from a visual standpoint. The materials that I'm about to describe are not manufactured in Sebastian, but are supplied from one of 2 materials suppliers that we use in the United States. If you're located in the eastern part of the United States, this materials drop shipment, which is what we call it, comes from Alexander Airplane Company in Griffith, Georgia. If you're primarily in the western United States, this drop shipment will probably come from Aircraft Spruce and Specialty Company in Fullerton, California. The materials that I'm about to describe are a part of your kit and paid for by Velocity. The shipping of this material to your location is your responsibility. Typically it's 8 to 10 UPS size packages that are delivered by UPS. First we'll talk about the various cloths that you're going to be using. The first cloth I'll talk about is unidirectional fiberglass cloth. In the manual you'll see it termed UNI, U-N-I. It is a cloth that has all the major fibers oriented in the same direction. It's used in the construction of the winglets. It's used in the construction of the winglet attachment to the main wing, and typically it's also used in the construction of the canard. The next cloth is called a bidirectional fiberglass cloth. Here again, in the manual we refer to this as BID, B-I-D. This is a coarse weaved fiberglass cloth with the major fibers running at a 45-degree angle to one another. We use this as a major structural type cloth for building bulkheads, attaching bulkheads to the fuselage, that kind of thing. There's another component that's very similar to a coarse weave bid, but it's a fine bid. In the manual you'll see it referred to as fine bid. It is identical to the coarse bid, except the weave is much tighter, so that the 45-degree weave is a much finer type weave. We use this in areas where the finished product needs to have a smoother surface. You'll see this used in the joining of the 2 fuselage halves together as an example. The final glass cloth that is used, fiberglass cloth, is a triaxial cloth, typically referred to in the manual as triax. Now, triax is the main cloth that you'll be using to build your wings. It's applied one time to the foam cores as the major structural cloth for the wings. All of these cloths get their strength from the addition of epoxy to their matrix. The main epoxy that we use and will be delivered to you is manufactured by a company called Hexcel. We use their brand called Epilite. In the manual, you'll either see the term Epilite or you'll see the term safety epoxy. Wherever you see Epilite or safety epoxy, we're talking about Hexcel's grade of structural epoxies that you see here. These are gallon containers. You'll also be receiving this type of epoxy in 5 and 2.5 gallon containers as well. This epoxy is applied to the cloths to give them their strength. The next thing you'll see in the materials drop shipment that I've described is various filler components. Now, the fillers are used, are added to mixed epoxies to create primary fillers. You don't mix any of the filler type components I'm going to describe in a moment with the epoxies and then add them to the cloth. The Hexcel products are added directly to the cloth without any additional products added to the mixed epoxies. These products will be shipped to you in double wrapped plastic type containers or packaging like this. The reason it's very easy for this material to become airborne. We would recommend that you transfer it from this type of container into smaller plastic containers for ease of accessibility. When you take these products, the first one I'm going to talk about is glass bubbles, and mix them with our epoxies that I'm describing, you get different components, different types of filler components. The glass bubbles, also referred in the manual as micro balloons, when mixed with an epoxy, is called a micro slurry. So whenever you see the term micro slurry in the manual, we're talking about the mixture of a glass bubble, sometimes referred to as a micro balloon, and the addition of a mixed epoxy. The two together, mixed to a certain consistency, create what we call micro slurry. You'll be putting micro slurry on top of foam cores prior to the addition of the cloth on top of those foam cores. The next type of product or filler component that you'll see in your drop shipment, again packaged in double wrapped plastic containers like this, is a product called milled glass fibers. Now, milled glass fibers are actually strands of glass fiber that have been chopped into small lengths. If you're primarily on the East Coast and get your shipment from Alexander Airplane, you'll probably receive milled glass fibers. If, on the other hand, you're located in the Western United States, the product you'll get in lieu of milled glass fibers is called flocked cotton, typically called flocks. The manual only refers to milled glass fibers, but you can use flocks anytime the manual calls for milled glass fibers. Flocked cotton is the same as milled glass fibers, but rather than chopped strands of glass fiber, it's actually chopped strands of cotton. Both of them can be used interchangeably. They offer the same structural characteristics we're looking for when mixed with epoxies. In the manual, this mixture of either flocks with milled glass fibers, when combined with the epoxies, is called microglass. So whenever you see the term microglass, we're talking about the mixture of one of these two type filler components with an epoxy. Going back, if we're talking about micro slurry, it's the mixture of glass bubbles with some of the epoxies I've already talked about. So there's micro slurry, which is glass bubbles, micro glass, which is mill glass fibers, or it could be flocks. The next type of resin I'll talk about are the filler type resins. These are typically used in fairly non-structural areas of the airplane. I don't think there's any place in the manual or the instructions that tell you to use the filler type epoxies with any of the glass cloth that I've mentioned. These epoxies, these filler type epoxies, are primarily used with either mill glass fibers or the glass bubbles as a filling component. You mix the filler epoxies to the right proportions and then add the fillers to create a product that can go on top of the glass and be sanded down to get the smooth finish that we ultimately want. There are two different types of filler type epoxies or non-structural type epoxies you'll be receiving. If you're getting your drop shipment from Alexander Airplane, chances are the filler type epoxy you'll get will be called alpha epoxy. If, on the other hand, you're getting your shipment from Aircraft Spruce, you'll probably get a product called West Systems epoxy. Here again, both of these are the same type or grade of epoxy used primarily in filling applications and mixed with either mill glass fibers, flocks, or glass bubbles. The next epoxy you'll be receiving in your drop shipment is a Hexcel product called 4-minute epoxy. This 4-minute epoxy is a very fast cure epoxy. It's not mixed with any of the fillers I've talked about. It's mixed in a 1-to-1 ratio and used primarily where we want to have very fast but not necessarily permanent type bonding in the airplane. Oftentimes this product is used to temporarily hold something in place while some of the other fillers and or epoxies are used to permanently attach it in place. It's here again a very quick setting 1-to-1 ratio type epoxy made by Hexcel. The next component we want to talk about are the tongue depressors that are used to mix the epoxies that I've talked about. Whether it be the 4-minute epoxy or the filler type epoxies or the epilite epoxies, they all have to be thoroughly mixed in order to be effective and to gain the kind of strength characteristics that we need. What you'll receive is a box of tongue depressors. It's a typical tongue depressor with rounded ends on both sides. What we typically do around here is square off one end of the tongue depressor, either with a bandsaw or breaking it off in a vise, so that when you do mix it in the cups you receive in the materials drop shipment, the mixing is a lot more thorough. You can scrape the bottom, you can scrape the sides, you have a flat edge to work with. It's very important that you get a very thorough mixture of the epoxy before you do anything with it, whether it goes straight onto glass or it's then mixed with the fillers to create a filling material. You want to make sure that the epoxy is mixed thoroughly first. So we would recommend squaring it off, cleaning up the edge, make sure there's no burrs there, and using that to mix your epoxies with. In addition, you'll also be getting paintbrushes, various sizes of paintbrushes in your materials drop shipment. These paintbrushes are used to perform a task we call stippling. And stippling basically is moving the epoxy material into and around and through the glass cloth. It's a jabbing action that occurs on the glass cloth to help it get saturated, to move epoxies around, to basically assist the epoxies in penetrating the glass cloth and making sure the glass cloth is properly saturated with the materials. The combination of the epoxy saturated in the cloth creates the structural composite that we need. So you'll have various types. There's both the 2-inch and the 1-inch paintbrushes. These are throwaway disposable type paintbrushes that are used to stipple the glass cloth and allow for the flow, the better flow of the epoxies throughout the material. That basically covers the raw materials you'll be receiving with the drop shipment from either Alexander Airplane or Aircraft Spruce. The next portion of this tape we'll go into will be a discussion on safety precautions we would recommend that you use when working with any of the materials I've described here. Well, now that you hopefully know a little bit more about the materials you'll be using at the constructor Velocity, I want to talk a little bit about the safety precautions we are recommending when you're using the materials that I've just described. All of the materials that we've talked about, glass, cloth, epoxies, filler components, whether it be glass bubbles or mill glass fibers, should be used with a certain amount of caution in mind. These are products that can become airborne rather easy, either when you're cutting cloth or mixing materials, especially the glass bubbles. And you don't want to necessarily inhale those products on a regular basis. It just makes common sense to protect yourself there. Before we get into that, though, we'll talk a little bit about protection of your hands and skin when you're mixing epoxies together. Whether it's the Hexel epoxy or the Alpha epoxy or West Systems epoxy, we'd recommend that you use some kind of protection on your hands and your skin to prevent the materials from getting on your skin. There are several things to do. Probably the most important thing is to work as cleanly as you can. They're the best protection against epoxy or the possible allergic reactions to epoxies is to prevent it from getting on your skin in the first place by working in a semi-sanitary type condition. Whenever you're working with epoxies, try to keep your arms covered, long sleeve shirts if possible. Make sure you use relatively older clothing, because once you get a mixed epoxy on your clothing, there isn't a detergent known to man that'll take it out. So you've pretty much dedicated that garment to mixing epoxy in the future. What we use typically here a lot are the standard latex exam type gloves. They are not necessarily the best type of glove to use. There are better gloves that are available on the market. This needs to be a decision made by you. There are butyl type gloves, other type of gloves, but these gloves fit very tightly to your hand and they're very easy to take on and off. Typically when I'm doing a layup on a wing or doing a lot of epoxy work during the day, I will change these gloves 4 or 5, maybe a half a dozen times in a 3 or 4 hour period. Whenever I see a slight buildup material, the glove comes off and gets thrown away. We buy these 100 pairs at a time at some of the larger discount warehouse stores for about $5 a box. So they're not an expensive item, and in my opinion, something that you can discard at a high rate to increase or decrease the likelihood that you're going to have any kind of allergic reaction with the epoxies. These epoxies have been developed to be relatively low in toxicity, so you probably won't have any problem at all. But this kind of use of gloves and also keeping yourself clean and keeping yourself covered will help you ensure that that isn't a problem and provide for a successful completion of your kit. Another glove that we've been trying lately is a vinyl type disposable glove. It doesn't fit quite as tightly as the latex glove, but some people have found that the vinyl type glove is a little bit better product as far as stopping the penetration of the epoxy components through the glove and into your skin. Regardless of the type of glove that you use, if you're going to wash cured epoxy, or correction, mixed epoxy off your skin, use straight soap and water, warm soap and water. Do not use a product like acetone. It will indeed dissolve the mixed epoxy, but it'll also allow it to penetrate into your skin a lot easier. Acetone is a vehicle that carries products with it quite easily and penetrates the membranes of the skin very quickly. So don't use paint thinners, especially acetones, those kinds of products to wash off epoxies. Use hot soap and water and do the best you can to keep it off your skin to avoid any kind of toxic or allergic type reaction. Generally, when people do get allergic reactions, although it hasn't happened but very little with any of my own personal building, I've never had an allergic reaction. It happens over a period of time. It's something that people abuse for a long period of time. Finally, your body gets to a point where it's had enough and you have a reaction to it. So you want to stop it before it ever gets started. I've been working with this material personally now for 10 years and I've never had any problem at all with any kind of adverse reaction to any of the epoxies that I've just described. The next thing we want to talk about is protection of your respiratory area, your lungs and so on. Before I talked about glass bubbles are microscopic glass bubbles. They're very fine, very similar to flour. And when you're trying to mix these glass bubbles with mixed epoxies, they become airborne very quickly. They're very irritating to the linings of your lungs. They'll make you sneeze right away. We're not recommending that you mix these kind of things unless you use some kind of protection. And it's really dependent upon you and your level of tolerance. Many people use the simple little masks that cover your nose and mouth with a rubber band that goes around your head. The next level up would be a disposable type mask. This is a 3M product that cost about $15. You can use this repeatedly by simply changing the outside filters of this mask. The inside filter is a carbon filter, doesn't do much, isn't really required for glass bubble stoppage, but the outside cartridge is a replaceable cartridge that builds up material on the outside. You can throw this away and replace it, put a new one back in, snap the outside cover on, and you have a good mask again. What we're doing here more and more, primarily because some of us here have beards, and the sealing of a beard against this kind of a mask is not very effective, is a air supply respirator type mask. This is sold under the trade name of Hobby Air. We have a piped system here where air from an outside source comes in through the tube and positively pressurizes the chamber, venting air out so that what you're breathing is an outside fresh air source of air at all times. I use this type of mask quite often, only because I'm dealing with epoxies and mixing materials quite often. I also wear a beard. I don't have to worry about it sealing against my face so much because there's always a positive blast of fresh air from an outside source coming into this mask. Now, I will tell you that there are many people who've worked for years without any of these safety precautions I'm talking about. This is really a decision you have to make. Quite frankly, they've done this quite successfully. On the other hand, I do know of individuals who have worked with this material without precautions, have developed an allergic reaction, and were unable to complete their projects. Or if they did, a lot of time had to be spent to make sure that they were in an environment where the epoxies and the odors and those kinds of things weren't being built up. So it would certainly delay your project and could possibly end it. We haven't seen this happen, but we would like to think that the reason is because people are taking some of the suggestions that we're recommending here. So I think that's enough about the precautions. The theme here basically is, if you're working this material, use common sense. Try to work in a semi-clean environment. Don't swim in this stuff. Get it off your skin when you get it on. Do the best you can to not get it there in the first place. The next portion we'll get into will be some of the equipment we will recommend using to build your velocity, specifically equipment used to mix the epoxies. In this section, what we want to do is talk a little bit about the tools we would recommend that you use to construct the velocity. This is a relatively dated chamber, a heating chamber that we use to store epoxies in, to at least store the epoxies that we'll be using in a relatively short period of time. It has a table on it. When it comes down, the top closes as well. Inside this chamber, we keep an epoxy pump. The manual describes two ways to mix epoxies, either with a balance type arrangement, a balance beam type arrangement, or using an epoxy pump such as that you see here. These epoxy pumps are designed to meter out the epoxies in the ratios that you need. If it's 43 parts of hardener to 100 parts of resin, which is the typical hexyl epilite requirement, you can buy a mixing pump that dispenses the epoxies and hardeners in those ratios simply by placing the cup underneath the outlet of the pump, stroking the pump. It'll fill the container to whatever degree you need. You can then use the tongue depressors that we've described earlier to mix them up. Again, all of this material, when it's dispensed into a mixing cup, whether it be with a pump like this or with pumping devices on top of plastic jugs like this, where in this case it takes one pump of that to two pumps of this to get the right mix ratio, or a 2-to-1 type ratio. When they're put into the cup, they have to be thoroughly mixed prior to any fillers added to the material, if indeed that's what you want to do. If you're going to be adding it to cloth, dumping it straight onto the cloth, here again, you want to make sure it's thoroughly mixed before you go any further. Now, we keep these materials in a heated chamber because the epoxies tend to flow better into and onto the glass when they have an elevated temperature. It's very similar to syrup that comes out of a refrigerator. If you heat it, it pours better. We maintain this particular chamber temperature at about 90 degrees, 90 to 95 degrees. It's not a problem here in the summertime, but in the wintertime when the outside air temperature is 40 or 50 degrees, we try to maintain the epoxies at about 90 to 95 degrees. We do this with a light bulb and a temperature sensing device that turns the light bulb on and off and provides us the temperatures that we desire. There's several ways to do this. Some people use old refrigerators with light bulbs, keeping the epoxies inside those refrigerators. There are many tricks to keeping an environment warm enough for these epoxies. You can create a little closet that's warm. Many techniques are used to elevate the temperature of the epoxy if the outside air temperature is relatively low. So that's basically, this particular chamber not only holds the epoxies that we're currently using, but I also keep various trowels, tongue depressors, mixing cups, stippling paintbrushes, various other products in here as well. The manual goes into basically what's required, necessary type tools, so I won't reiterate that. It talks about drills and screwdrivers, drill bits, those kinds of things. I will talk about some of the equipment that you might want to purchase that will make it even a little easier to build your kit. An example are a couple of pieces of equipment that I have here on the bench. A small bench 8-inch drill press has been used a lot in the construction of airplanes, as well as a vise, a drill press type vise device that holds material in place while you're doing your drilling. These are relatively inexpensive. This happens to be a Sears model. It's been used for several years and has given good service. It isn't something that's necessary in the construction of your velocity. You can do most of it with a drill, a hand drill. This gives you a slight better advantage as far as accuracy goes and control. The next thing that I personally use a lot is a 6-inch bench grinder. On one side I have a grinding wheel, the other side I have a buffing wheel. There'll be a lot of little parts here and there that you want to clean up in some fashion. Either you'll be fine-tuning them to fit a particular area that you're working on, or you may be creating your own little product and you might want to grind it, change it, modify it, and when you're done, buff it out to do that as well. Another device that we use in cold climates, or when the temperature goes down and you don't have a heated space, are these heat and strip type devices. They're really just powerful industrial hair dryers. We use this to help the epoxy move throughout the fiberglass matrix. In conjunction with some of the trowels and stippling brushes that we have, we can make resin that is semi-cured or relatively cold move more freely by the application of heat. As you can tell, this particular gun has been around for several years and is still quite effective in its job. It'd be a good idea to get some large plastic type garbage cans. You'll be using them a lot. You generate quite a bit of trash in the way of paper, plastic things that protect floors so that you don't get epoxy on floor, that kind of thing. You want to make sure you have a good garbage can nearby to pick up that trash. One of the things that we've found very effective, when you get your kit components, everything is identified, all the hardware is identified by a label packaged in a plastic bag. This wall right here shows what you get with the wing kit alone. The fuselage kit, or that portion of the hardware, will go up on this wall when we finish the wings for the particular airplane we're working on now. For the time being, it's still packed in the original boxes we received it in from our factory in Sebastian. But if you place the products up on a pegboard in this fashion, it's very easy to identify what you want. If the manual calls out for a certain size bolt, an AN3-11A, you can quickly scan this area, find the particular bolt that you want, open the bag, take it out, put it back. We found this to be a time saver. Used this in the past. It's something that can be used to make your project go a little smoother and less hassle. We use a lot of shop air in our work, both for cleanup, for air tools, for spraying our airplanes when we're done paint spraying them. If you're going to be ultimately painting your airplane, which is not a difficult task. It certainly is something that you can learn how to do. I did. I never painted any kind of vehicle until I painted an airplane. You would definitely want at least a 5 horsepower compressor, especially if you're using that compressor for driving any of the pneumatic type sanders that are available today, the pneumatic board sanders. All those type of devices, whether they be a spray gun or a pneumatic board sander or a DA type sander, the orbital sanders, all require a fair amount of air. A 5 horsepower compressor is probably going to be a minimum. If you're not planning on using that equipment, if you're planning on having somebody else paint the airplane, or if you're going to sand most of the airplane by hand or using electrical type sanders, which is not uncommon at all, then probably a 3 horsepower air compressor would be sufficient. Organizing your tools in bins like this certainly helps, so that you're not scrambling at a critical time to find the particular tool that you're looking for. The other thing that is mentioned in the manual and you see here are benches. We have some permanent type benches built into the walls. Generally these benches are fairly level and straight and true, because we might be putting components or building components on top of those benches that we want to have very level, very straight. Other benches are fabricated from doors and sawhorses. You'll want a fair supply of sawhorses, at least a half a dozen sawhorses, and a couple of doors to create benches or workstation tables for your project. We'll get into that more later on. Further on down the line, we're not going to walk down there for the time being. We also have a bandsaw. Here again, not necessarily a device that you have to have. A small handsaw, saber saw, or a hand hacksaw will be more than sufficient, but a bandsaw will make the project go just, again, that much faster. A little later on, we'll get into the sawhorse application and how you start using some of those devices to support your products, wing components, while you're constructing them. With the last portion of this introductory tape, we're going to discuss a little bit about the products, a little bit more about the products you'll be receiving, primarily the large products that are manufactured in Sebastian. We've talked about the materials drop shipment, we've talked about safety precautions, and a little bit about the tools you'll need. Now I want to get back into the larger components. Probably one of the first things you'll see coming off the shipping container, out of the shipping container, are the styrofoam billets that have the pre-cut foam cores still nested inside the original billet. This particular foam core that you see right here is a trailing edge of a wing foam core. It's already been pre-cut with a hot wire technique at the factory in Sebastian. It's delivered to you in its original billet form, safety wrapped for protection. The original billet is what protects the finished product that you see here. All these components come to you as part of your kit. Again, all the foam cores are pre-cut and stored inside the original billet they were cut from. You also get a lot of pre-manufactured components with your kit. As an example, you'll see this wing spar mounted on the sawhorses. The wing spar is a prefabricated molded product that's built in Sebastian. It already has the hard points, the wing hard point attach points molded into it. And you can see here we've started the process of putting the foam cores onto the wing spars. These are the leading edge foam cores that will eventually be bonded to the spar and then wrapped with fiberglass. One of the items that's very important is how to use a level in the process of building your velocity. The manual goes into this to a great degree, but I'd like to reiterate it here. All of your levels should be calibrated and used in a consistently the same type manner. The way we do it here, we have a top label for every level. We also have a set of bubbles that we use all the time, and we have the word right on a level. So whenever we're using this level, this is always the top, and we're always looking at the right-hand word in the right-hand position. We consistently use this level in this fashion no matter where we are on the airplane. If we're leveling across the hard points to get this particular wing spar level, we're going to have a top and we're going to have a right. We'll read the corresponding correct bubble. We do that consistently throughout the entire project. As you can see here, this is where sawhorses become useful and required in order to build your wing. We'll get into the construction of the wing in the next section or the next tape. I'm just for the time being giving you an idea of what you'll get with your kit. That was the right wing. This is the left wing. Here again, a pre-molded spar comes with your kit, as do all these foam cores. I've already taken these cores out of the billets, and they're now being prepared to become part of the wing. Here again, you can see the use of the sawhorses in the area. You're going to need several sawhorses to efficiently complete your project. Also with the kit, you'll get the pre-molded fuselage body itself. It comes in two parts, a top part and a bottom part. It separates with this flange. Ultimately, this flange is cut off. We've got it again set on some sawhorses to get it off the ground. When we start working with this, we'll be removing the top portion of the fuselage, working on the bottom portion first, completing as much as we can on the bottom portion of the fuselage prior to placing the top portion of the fuselage in place. Once that's done, fuel strakes are added. There are many other components that come with your kit. Pre-molded fuel strakes, tops and bottoms, left and right. Center section spars, very similar to the wing spars that you see here, come pre-molded with your kit. Numerous other fiberglass components, fairing devices, and the like. Ultimately, when you're finished with your project, when you've finished the entire project, you're going to end up with an airplane that looks like this. This is the end result of your labor. It's an absolutely delightful airplane to fly. This one was built in April of 1994. It now has about 250 hours on it, and it's used as the primary demo airplane here at Velocity West in California. Ultimately, we'll be building a new demo plane, a 173 fixed gear airplane with the new Elite door option, or the new gull wing door option, and we'll be videotaping that process as well. For the time being, that pretty much ends our introduction to the materials you will be working with, the safety precautions and the like. The next portion of this tape will be getting into the construction of the wing itself. The wing we'll be building is a 173 wing, and that'll be the next thing you see in our series of tapes. Thank you.